Sixth grade lesson 13.8. This is the last lesson in the book, the sixth grade book, problem solving and misleading statistics. So we're still going to be looking at that mean and that median, measures of center, mode, those sorts of things. But we're also going to look at how sometimes the information could be misleading and how we can make sure we aren't misled by the information that we're given, that we know enough so that we can catch or understand the data that's being given to us, so we can have a good indication of what the real information is. And we'll start this lesson as an example with Mr. Owen's story about him wanting to go to a place that has a perfect temperature. Let's look at the unlock the problem. Mr. Owen wants to move to a town where the daily high temperature is in the 70s most days. I hear you, Mr. Owen. That's where I would like to live. A real estate agent tells him that the mean daily high temperature in a certain town is 72 degrees. On average, most days are 72 degrees or right around there is what the real estate agent tells him. Other statistics about the town are given in the table here. Does this location match what Mr. Owen wants? Does it match what the real estate agent said? Let's find out. I need to decide if the daily high temperature in the town is a mean temperature of something in the 70s. Mean in 70s. What information do I need? I need the information in the table, this stuff. And over here in the table, they tell me what the minimum temperature in the past year was, 62 degrees. The maximum temperature, 95 degrees. That's just a little bit more or a lot bit more than the 70 degrees that Mr. Owens was hoping for. For us here where I live, that's a nice cool day when we're sitting at 115 to 120 in the summertime. But for Mr. Owen wanting a 70-degree temperature, 95 is high. So maximum is 95. That means there's probably some in between that 95 to 70 degree section. Median is 69 and the mean is 72. And so the real estate agent tells him the mean is 72. And at first, Mr. Owen's like, oh yeah, see, that's what I'm looking for, an average temperature of 72. But remember our outlier thing in our previous lessons? If there's a big outlier, there's a big outlier, it can draw the center of the measure of center as a mean upward a little bit, skew it a little bit. And so sometimes the mean might be a better idea of what the measure of center is. Look at our median, because we look like we have an outlier there. So that's probably what's going on here. We may have misleading data. How will I use this information? I'll work backward from the statistics and draw conclusions about the set of data. We can only draw conclusions about the set of data because we don't have the set of data. We just have the numbers they worked. And we already were kind of doing that when we were talking about this difference between the median and the mean. You guys now understand that those are measures of center, but the mean can be skewed one way with a big outlier. So we're looking like we're seeing that. We have the minimum high temperature of 62. That's a little lower, a little cold for Mr. Owen. He wants it to be in the 70s, between 70 and 79. Nice, perfect weather, right? So they want us to think the high temperature is sometimes less than 70, right? If it's 62, that's less than what he wanted. The maximum high temperature is 95, and for somebody wanting 70-degree temperatures, that's hot. The high temperature is sometimes higher than 80 degrees. He wants it in the 70s to 80s range, and so sometimes it's higher, and that's pretty significantly higher than 80 degrees. The median of the data set is 69. And what that really means is that's the middle value of the data set. So half of the data is below that and half the data is above it. So if half the data is below that, then it's lower temperatures than 69. He wanted a place where it's between 70 and 80 degrees. Because the median is 69 degrees, at least half of the data must have high temperatures less than or equal to 69 degrees. So this location does not match what Mr. Owen wants. The median indicates that most days don't have a high temperature in the 70s. At least half of them half of them have temperature below 69. And then the other half, at least some of them, are above 80 degrees. We know at least one of them is above 80 degrees. So it was a little misleading that when the real estate agent said, oh yeah, our mean average temperature here is 72 degrees, and Mr. Owen is thinking, oh, that's super nice. I like that. But in reality, there was this big outlier that skewed the data higher. In reality, it's a little lower than the temperature Mr. Owen was hoping for. He's going to need a jacket all the time. He doesn't want to have to wear a jacket all the time. So that's what they mean by watching for misleading statistics and being able to recognize those. Let's look at one more example. This is Miss Garcia. She's going to buy a car. So let's hear her story. And they're going to use a box plot to help us visualize the information also. Okay, Miss Garcia is buying a new car. She would like to visit a dealership that has a wide variety of cars for sale at many different price ranges. The table gives statistics about one dealership in her town. Does the dealership match Miss Garcia's requirement? Okay, so she wants the car dealership to have a wide variety of cars for sale at many different price ranges so that she can get an idea of what she's looking for. She's looking for a car dealership that will have cheaper cars and more expensive cars and everything in between evenly spread. So if we're looking for things to be evenly spread out, we're looking for ranges, right? The range or the interquartile range for the box plot. We're looking for those to be well spread out. Okay, so let's see if this information is well spread out. We want to know the ranges. What do I need to find? The range or the interquartile range? I suppose this probably should have gone here. Range or interquartile range. What information do I need? I need to know those things. I want to find a variety is what I really want. So let's change that to that. Sorry about that. A variety of prices. A spread. Spread variety. How will I use the information? We'll go ahead and make a box plot because the box plot gives us the range on the whiskers, right? And then it also gives us an interquartile range where the majority of the data is at. So that will give us an idea of what the spread looks like in the entirety and what the spread looks like where most of the data is at. And that should give Ms. Garcia an idea. Does this dealership have the variety that she is looking to view? All right. So here they give us information that will help us form a box plot. The lowest price car on their lot is $12,000. That's going to be right about here. The highest price car is a $65,000 car right there. The lower quartile price is $50,000 here. The median is $55,000. And the upper quartile is $60,000. Now, take a look at that. Take a look at that and put into that context what you know about interquartile ranges and range. Do they have the variety based on the range? It appears so. But when you look at this interquartile range, the majority of the cars that they have on their lot are at this price range. That's the majority of them. This is an outlier way down here. So it feels like what this car lot has done is they've put some very expensive cars on their car lot. And just so that people like Miss Garcia will think, oh, but we have very affordable cars. They have one little car over here at $12,000. And they can say, oh, yeah, no, we have a huge variety of priced cars. But do they really? Not really. They have lots and lots and lots of cars that are very expensive and then one or two cars that are not. And they're probably not the cars that you're hoping to see. So the variety there is not the variety that Miss Garcia is looking for. So what would the box plot look like for the dealership that does meet Miss Garcia's requirement? Remember, she wants a very wide spread. The range only tells us the most expensive and the least expensive. But the interquartile range tells us where majority of the data is located. She's hoping majority of the cars are in a price range that's spread out quite a bit over the price ranges so she can really decide what's best for her. we'd be looking for a box plot that has the box interquartile range really spread out. That's what she would be looking for. So when she decided, am I going to this car dealership? And she had this information. If she plotted that out, she'd go, no, because they don't have a variety. They have very expensive cars, and that's pretty much it. And if she looked at a car dealership that she plotted out their data, and she said, there's a wide variety of cars that I can choose from. I'm going to go there. I hope these explanations helped you see where they're going with this lesson. It's just now applying the knowledge and allowing yourself to not be misled by information because you understand how data is plotted out. You understand that the average is the mean can be skewed a little bit, so knowing the median too will help you understand the data better. You understand that the range may tell you a bit of the story like it does here, but the interquartile range will tell you a deeper story of variety. Hopefully that all made everything fall into place. I hope you had a really great 6th grade year, and I've got a whole list of 7th grade math lessons, so if you need help in your 7th grade math, I'll be there for you. Also 8th grade too. All right, have a great summer once you finish the rest of your school year off. I'm very proud of you. Good job.